Mr. Mack. We're going to do question number 19 now. And we have a class of 30 studies. It's probably 30 students. One foreign language and one science class. And the students' choices are in the table. Now, A says, find the probability that a randomly chosen student studies chemistry. So our universal set, the randomly chosen student, there's 30 in that set. And then the student studies chemistry. Well, if you look down there, there's 7 French students studying chemistry and 7 Spanish, so a total of 8. So 8 over 30 becomes 4 over 15. Now, the second one says, find the probability that a randomly chosen student studies chemistry given that the student studies French. Okay, now, that one is a conditional probability, and so it is the probability of, or actually, let's just say the number of students that are in chemistry and French, so chem intersect French, over the number in French. So chem intersect French is this 7 right here, and the number in French is this number right here, so we end up with 1/2. For the probability that a randomly student studies chemistry given that the student studies French. Now, part C says, are the events student studies chemistry and student studies French independent? Well, the intersection of chemistry and French, the probability of that is 1/2. We just did that on part B. Now, the probability that a student studies chemistry is 8/30. And the probability that a student studies French is 14/30. And for these two events to be independent, 8/30 times 14/30 has to be equal to 1/2. It's pretty obvious that it isn't. 8 times 14 is 80, 112 over, so we get 112 over 900. And that'll reduce some, but it certainly doesn't reduce to 1/2. So the answer is no, they are not independent. And it is time now for